Have you ever wondered how programs interact with external data sources? This interaction is a fascinating dance of input and output, often referred to as I/O and file processing. I/O is the communication between an information processing system, like your computer, and the outside world, possibly a human or another information processing system. The input is the data received by the system, while output is the data sent from it. Now, let's talk about standard input and output, or as the cool kids call it, STID-in and STID-out. These are the default input and output streams of your system. The STID-in is typically connected to the keyboard, allowing you to input data directly into the system. On the other hand, STID-out is usually connected to the screen, displaying the results of your program's execution right before your eyes. Now, you might be wondering, how does file processing fit into all of this? Well, file processing is a way for programs to store data for later use. It involves reading data from files, input, and writing data to files, output. Before a program can read or write to a file, the file must be opened in the appropriate mode, whether that's for reading, writing, or appending. It's also crucial to close the file once operations are complete to ensure data integrity and free up system resources. In essence, understanding I/O and file processing is fundamental when it comes to developing practical and versatile applications. It allows your programs to interact with external data, store information persistently, and even share data between different instances of the same program or entirely different programs. Now that we have a basic understanding of what I/O is, we move on to how it is implemented in programming. How do we implement I/O in programming languages such as C++ and Python? Well, let's dive right in. In C++, we utilize the IOStream library for standard input and output operations. Let's say we want to accept a number input from the user. We use std_sin to capture the user input. To print the input back to the user, we use std_count. It's as simple as that. In Python, the process is even more streamlined. Python has built-in functions called input and print for handling standard input and output. We use the input function to get a number from the user and convert it to an integer using the int function. Then we print the input back to the user with the print function. Now you might ask, what if we want to read from or write to a file? Well, that's where file processing comes in. Before we can read from or write to a file, we must first open it. In C++, we use the fstream library to handle file operations. To write to a file, we create an instance of std offstream and use the insertion operator to write to the file. To read from a file, we create an instance of std ifstream and use the getLine function in a loop to read each line. In Python, we use the open function to open a file. To write to a file, we open it in W mode and use the write method. To read from a file, we open it in R mode and use a for loop to read each line. Always remember to close your files after you're done with them. This releases system resources and ensures data integrity. And that's how we implement I/O in C++ and Python. Now that we've seen how I/O works in these languages, let's discuss file processing. What is file processing and why is it important? Now that's a great question. File processing is the method by which a program reads from or writes to a file. This is crucial in programming as it allows programs to persist data, exchange information, and interact with external data sources. Consider a scenario where you've created a fantastic program. It's perfect. But wait, it only operates with data you've manually inputted each time. Now this might work if you're only dealing with a small amount of data. But what if you need to handle a large database or interact with another program? That's where file processing comes in. Before a program can read from or write to a file, the file must be opened in the appropriate mode, such as read, R, write, W, or append, A. And don't forget, once you're done, always close the file. It's not just good manners, it's crucial for data integrity and releasing system resources. Let's see file processing in action in the next scene. How do we handle file processing in C++ and Python? Well, let's dive right in. In both C++ and Python, the process starts with opening the file. We use the offstream function in C++ and the open function in Python. We then specify the file name and the mode, which could be W for writing, R for reading, and so on. To write to a file in C++, we simply use the insertion operator, just as we would with count. In Python, we use the write method. Remember to always close the file after you're done to free up system resources and ensure data integrity. Reading from a file is also straightforward. In C++, we use the ifstream function to open the file and then use the getLine function in a loop to read each line. In Python, we use the read method or iterate over the file object to read line by line. Now, let's talk about the output. In C++, the output appears on the console thanks to our friend Coot. In Python, the print function does the job. But the real magic is happening behind the scenes, as each line from our input file is being read and displayed. There's something satisfying about seeing the words "hello file" appear on your screen, isn't there? It's a testament to the power of file processing. You're not just communicating with the user anymore, you're interacting with the wider world of data stored in files. And what if you want to read and write structured data, like objects or structs? Well, that's where binary file I/O comes in, and it's a topic we'll be exploring in more depth shortly. Now that we've seen how file processing works, let's delve a bit deeper and discuss binary file I/O. In the next scene, we'll be diving into the nitty-gritty of binary file I/O in both C++ and Python, so stay tuned. What is binary file I/O and how is it different? Well, binary file I/O involves reading and writing data in binary form. Unlike text files where data is stored as readable characters, binary files store data in a format that is only intended to be read by machines. This makes binary files especially useful for storing complex data structures or large amounts of data efficiently. Let's see how this works in C++. We start by defining a structure, data, which holds an integer and a double. We then create an instance of this structure and write it directly to a binary file. We use the write function, which requires a character pointer and the size of the data we're writing. Here we use reinterpret_cast to convert our data to a character pointer. Next, we open the same binary file for reading. We create another instance of data to hold our read data. Once again, we use reinterpret_cast to convert our read buffer to the correct data type. After reading, we can access the data fields just like any other structure. In Python, we use the struct module to handle binary data. We create a binary string from our data using the pack function, specifying the data format with a format string. Here, I stands for integer and D for double. We then write this binary string directly to a binary file. Reading from a binary file in Python is just as straightforward. We use the unpack function, providing the same format string and the binary string read from the file. This gives us a tuple of our original data. Remember, binary files are not meant to be human readable. They offer a way to store and retrieve data in its native binary format. This is especially useful when working with large data sets or complex data structures. We've now seen how binary file I/O works. Remember, always handle files appropriately to ensure data integrity. What are the key points to remember about I/O and file processing? Let's quickly recap. I/O, or input-output, is all about how a program interacts with external data sources. Standard input, typically from a keyboard, and standard output, usually to a screen, are the primary conduits for this interaction. When it comes to file processing, remember to always open a file with the appropriate mode before reading from or writing to it. This could be R for read, W for write, A for append, or B for binary, among others. And don't forget to close the file once you're done. Checking the success of file operations is crucial. Always handle errors appropriately to maintain data integrity and a smooth user experience. When dealing with structured data, be mindful of binary file I/O and data serialization. Understanding I/O and file processing is fundamental for developing practical and versatile applications.